This is a video lesson for free fall motion calculations. The essential question for this lesson is, how can I calculate the velocity and height of objects in free fall motion? Let's talk about free fall motion. So an object in free fall experiences only one force, and that is the force of gravity. So if we ignore drag, gravity accelerates all objects at the same rate, which is g. And on Earth, g is, as we know, 9.8 meters per second squared, or as we often approximate it, 10 meters per second squared. All right, so let's look at kinematics equations in the y direction. So free fall motion is accelerated motion. And it's accelerated motion in the y direction, or the vertical direction. And we call that acceleration minus g. And we use the kinematics equations in the y direction. So we have here our standard kinematics equations that we used in one-dimensional motion. Just now we have them in the y direction. So instead of x, we have y. Instead of x naught, we have y naught. And velocity is in the y direction. So we have vy naught times t, 1/2 a t squared. We have velocity squared in the y direction, velocity naught y squared, and so on. All right, let's look at a little bit of additional information about free fall motion. So at an object's maximum height, starting here about max height, its velocity in the y direction is equal to 0 meters per second. Free fall is symmetric, going up and down. For example, a projectile launched upward will take the same time to fall from its apex as it took to rise to its apex. So if we have a ball here and we throw it up, the amount of time it took to get up is going to be the same amount of time it takes to get down. So time up equals time down. Additionally, at a given height, a projectile will have the same speed going down as it did when going up. So if we looked at a projectile's trajectory, it goes up and it comes back down again. At this point in its upward trajectory, it's going to have the same speed, the velocity, as it does going down. All right, let's look at solving some free fall problems. So for example 1, for fun, I pushed a physics textbook out of a 20-meter high window. What was its velocity impact and how long did it take to hit the ground? Okay, so we have our y. So let's say y naught is equal to 20 meters. Y is 0, because that's y naught is our starting height and y is our final height. Our v naught is equal to 0 meters per second. We know our acceleration, which is equal to minus g, which is equal to minus 10 meters per second squared. And we want to know how long did it take. So t equals question mark. Right, y equals y naught plus v naught y times t plus 1/2 a t squared. So y is equal to 0 meters, y naught is equal to 20 meters, plus v naught y is equal to 0 meters per second, times t plus 1/2, and then a is equal to minus 10 meters per second squared, and then t squared. So we have 0 equals 20 meters minus 5 meters per second squared times t squared. So we'll move the 5 meters per second squared times t squared over to the left side. So we have 5 meters per second squared times t squared equals 20 meters. Divide both sides by 5 meters per second squared. So we have t squared is equal to 4 seconds squared. So then take the square root of both sides, and we end up with t is equal to 2 seconds. Okay, let's look at problem number 2. An archer stands on a 15-meter tall wall and fires an arrow with an upward velocity of 30 meters per second from that height. What is the arrow's maximum height above the ground, and how long does it take to hit the ground? So how long does it take? All right, so let's draw a little diagram here. So we've got a wall that is 30 meters high, or excuse me, 15 meters high. The arrow shoots up, and then it comes back down and hits the ground somewhere here. Okay, so we can solve this several different ways, and I'm going to show you different ways to solve it. So let's start with, we have y naught is equal to 15 meters. And we want to know, and we have a velocity naught, v naught y, or v y naught is 30 meters per second. Okay, and we want to know y, and we want to know t total. Okay, so actually we should call this y max, the maximum height. Okay, so this is the maximum height up here, so this would be y max. Okay, and then we want to know how long it takes to follow this whole trajectory. So what's the time, the total time? Okay, so we're going to start using our kinematics equation, Vy. So Vy squared equals Vy naught squared plus 2a times y minus y naught. So notice, or remember, that whenever you get to the maximum height, so the velocity of y at y max is equal to 0 meters per second. So we can use this information to help us figure out what our maximum height is going to be. So our Vy at maximum height is going to be 0. We have our initial velocity of 30 meters per second. So 30 meters per second, we're going to square that, plus 2 times our acceleration, and this is always negative g, so that's minus 10 meters per second squared. And then we have y, which is our maximum height, which is what we're trying to figure out in this problem. So y max, and then that's minus our 15 meters, which is our initial position. Okay, so we'll start to simplify this, do a little bit of algebra. So we have 0 is equal to 900 meters squared per second squared. And then we multiply this out. So we have 2 times negative 10, that gives us negative 20 meters per second squared, times y max. So that's minus 20 meters per second squared times y max. And then plus, it's going to be 20 times 15. So that's 300. Meters squared per second squared. Okay, so now we want to simplify. So we've got this 900 meters squared per second squared plus this 300 meters squared per second squared. So that gives us 1200 meters per second squared. And we've got this negative 20 meters per second squared times y max. We're going to move that to the left side of the equation. So we have 20 meters per second squared times y max. And that's equal to 1200 meters squared per second squared. So divide both sides by 20 meters per second squared, and we end up with a y max of 60 meters. So when the archer shoots the arrow from 15 meters, from a 15 meter tall wall with an upward velocity of 30 meters per second, it reaches a maximum height of 60 meters. Okay, so now that we have our maximum height, now let's figure out how long it takes to hit the ground. So we're going to use this equation again. This time, though, we're going to figure out from the maximum height to the ground. So we're going to figure out the time it takes to go from here down to the ground. To do that, I'm going to clear off some space, and then we will start working from there. Okay, so now we're going to figure out the velocity that it takes to go, or the velocity that the arrow reaches from the maximum height down to the ground. So we're going to say that our v naught y from at the max height is 0 meters per second, and we're trying to figure out vy. So we have vy squared is equal to 0 meters per second plus 2 times minus 10 meters per second squared times, and we reach a height of 0, and we start at a height of 60 meters. So if we do some simplification here, we have vy squared equals minus, that actually ends up being a plus, 20 times 60 is 1200 meters squared per second squared. So if we take the square root of that, both sides, we end up with vy is equal to 34.64 meters per second. Okay, so now we have that. Now, so this is the velocity that the arrow reaches from the maximum height down to the ground. So now we can use the equation vy is equal to v naught y plus acceleration times time to figure out our time. So this is going to be the time from the maximum height down to the ground. So our vy is 34.64. That's equal to our velocity at the top at the maximum height is 0 minus 10, that's meters per second squared, so that's the acceleration, times t. And this actually velocity should be negative because it's falling towards the ground. So it should be a negative velocity since it's going from up to down. So that gets rid of our negative sign there. So the time it takes to go from the maximum height to the ground is 3.46 seconds. So now we just need to figure out how long it takes to go from our starting point to the maximum height. So we can use this same equation again. So our initial velocity is 30 meters per second, and our final velocity to reach the max height is 0. So we have 0 is equal to 30 meters per second minus 10 meters per second squared times t, which gives us a time of 3 seconds. So our total time is equal to 6.46 seconds. So the y max, the maximum height the arrow reaches, is 60 meters. And the time it takes in the air from when it's launched to where it hits the ground is 6.46 seconds. Now there is another way to do this problem using the quadratic equation, and I'm going to show y'all how to do this problem again using that method. I'm going to do that on a separate slide. Okay, so now we're going to work this problem using a different method. This is the quadratic equation method, or the quadratic formula method. Okay, so we've got the archer. He's standing 15 meters above the ground. He launches his arrow up with a starting velocity of 30 meters per second. So Vy naught is equal to 30 meters per second. So we want to know the maximum height above the ground and how long it takes to hit the ground. So we're going to use this kinematics equation, y equals y naught plus v y naught t plus 1/2 a t squared. And if you'll notice, this equation is in the form of a quadratic equation, where we have the quadratic term, we have a linear term, and then we have a term with no power to it, with no variable. Okay, so let's fill this. Let's rewrite this equation with all the numbers in it so that it's correct. So our y is going to be 0. Our y naught is 15 meters. Our vy naught is 30 meters per second. That's times t. Plus, and we have 1/2 times -10 meters per second squared, and that's times t squared. So if we simplify all this, we have 0 equals 15 meters plus 30 meters per second times t. This becomes minus 5 meters per second squared times t squared. Now, because each of these coefficients in front of our t squared, our t, and then this non-variable term are all divisible by 5, we can simplify this. We just divide everything by 5. So then we have 0 is equal to 3 meters plus 6 meters per second times t minus 1 meter per second squared times t squared. All right, now let's rewrite this such that it is in the correct quadratic equation order. So I'm going to move the t squared term to the left side of the equation and move everything else over there. So we have 1 meter per second squared times t squared minus 6 meters per second times t minus 3 meters is equal to 0. So this is our A, this is our B, and this is our C. So remember that the quadratic formula is B plus or minus the square root of B squared minus 4AC over 2A. And this is solving for t. So this is going to give us our time, t. All right, so let's figure out our time. So we have B, which is minus 6 plus or minus the square root of B squared. So that's 36 minus 4 times A, which is 1, times C, which is minus 3. And that's all over 2 times A, which is 1. All right. Now we're going to simplify this down. So we have minus 6 plus or minus, we have the square root of 36. We have, so this is minus a negative 3, so that's plus 12. And that's all over 2. So we have minus 6 plus or minus the square root of 48. Divided by 2. And when we figure this out, we have the following answers. 0.464 and 6.464. All right, so we know that this answer is correct, 6.464. So looking at the two answers, it doesn't make any sense that the arrow could have gone 15 meters into the air and then fallen another so it couldn't have gone 60 meters up into the air from this 15 and then fallen down that far in 0.464 seconds. So the only time that makes any sense is this 6.46 seconds. So this is the correct answer here.